Hello, and welcome to this session on Bridge Design Pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. What is Bridge Design Pattern? The bridge pattern is a design pattern used in object-oriented software development that aims to decouple an abstraction from its implementation, allowing both to vary independently. It involves creating two separate hierarchies of classes, one for the abstraction and one for the implementation, and then connecting them through a bridge object. The main objective behind the bridge pattern is to separate an abstraction, such as an interface, abstract class, or API, from its implementation, the actual code that provides the behavior. By doing so, changes to either the abstraction or the implementation will not affect the other, making the system more flexible and easier to maintain. The bridge pattern typically involves creating an abstraction class or interface that defines the method and properties that client will use, and then implementing that abstraction in concrete subclasses or classes that provides the specific behavior. The abstraction class will then use an instance of the implementation class through a bridge object to perform the desired behavior. Hello and welcome back. Let's refactor a car class that has an engine using the bridge design pattern. In this code, we have a vehicle class that has a start engine and a stop engine method. And this vehicle class has two subclasses that create a car and a motorcycle. And then it has, for the car, it also did an extra method called drive. And then for the motorcycle, it has an extra method called ride. So if you want to call a car, you want to start a car, I'm just going to uncomment this, and you can see I started a car, BMW car, started the engine, drove the car using the drive method, and then stopped the car. I also did same with the motorcycle, and you can see started and had the Davidson motorcycle, started the engine, rode the car, and then also stopped the engine. The problem with this design is that the vehicle class is tightly coupled to the specific behavior of the car and motorcycle classes. To adhere to the single responsibility principle of the solid principle, we're going to remove the implementation from the abstract class, which is the car. To do that, the first thing we're going to do is create a vehicle that is, and the vehicle takes in an engine. Like we rightly said, we want to create vehicle and then engine. The vehicle is going to be at the abstraction, and then the engine is going to be the implementation. I'm going to create the other methods for vehicle, but I just want to create the engine, the implementation, so that you could see it separately. This is the implementation, that is the attributes or the behavior of the vehicle. And this is the abstraction class. So the abstraction class is the vehicle. The implementation, that is the engine, has a start and stop method. And from the vehicle, when I create any vehicle, I should be able to start and stop that vehicle from the vehicle type. So that means I'm going to create a start and stop method, which becomes the bridge between the vehicle and the engine. So I'm going to say, do a start engine method. I'm going to start the engine. You see, I already entered the engine when creating the vehicle. Start the engine and implement the start method that the engine gives me. And I'm going to do the same thing for stopping. So I'm going to change this to stop. So when I call the vehicles start and stop, it's going to call the engine start method and the stop method. So this method becomes the bridge between the two abstraction and implementation. Now let's create vehicle types. And I'm going to just implement an extra method that I call drive. So right now, because I inherited the vehicle, it also inherits all this method that are created underneath. So I'm going to do for motorcycle and then also create an extra method that I will call ride, that rides the motorcycle. Now this is the abstraction. And now for the engine implementation, I can also have different type of engine. I can have a car engine, which implements the start method and also the stop method of its superclass. Let me do another subclass for motorcycle engine, and I'm going to implement the start and stop method for motorcycle engine as it's implemented here in the engine. So the implementation are the behaviors that we're breaking apart from the code from the vehicle. Let's implement another type of engine also. We have a motorcycle and car engine, and let's have a truck engine. This truck engine also has the stop and start. So we can create different engines and then merge it with different vehicle types. So right now we have a different abstraction, that is different type of vehicles, and then we also have different type of engine. So let's do a car engine, which is car engine. Let's instantiate the car engine and then call the car engine inside a car. A car takes in an engine, and that is a car engine. Let's start the engine. Start engine. It's a car, so we can drive it. The car is driven. You can see it's the output showing here. It's a car. We can stop the engine also. Car engine is stopped. And the beauty is that we can also create the second car with a truck engine. And then we can start the engine. You see, okay, let me comment this out. Car 2. You see, truck engine is being started even though it's a car. And then we can also drive it. And then we can stop the engine. This we can also do with the motorcycle. I'm going to comment all these out so we can see the motorcycle example. It's just the same thing, but this time we're implementing the abstraction, the motorcycle abstraction, and putting in a motorcycle engine in it. We started the engine, we rode the engine, we rode the car, the motorcycle, and then of course we can also stop the engine. So you can see we were able to separate the abstraction, the vehicles from their engines, and then we're able to bridge them together using the abstraction methods here. They all work seamlessly together. So we can create more cars and we can create different engines, and then we can also bridge them together to work together the way we want. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with Real-World Code Examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, catch, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chat applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.